here I will dig you into a little bit of history, of course. So as I'm explaining the facts, I would like to just write the content over here so that you might get a clear idea. What exactly this Spring is an open source project, and it is in the industry since February 2003, and it's having a long heritage since those years. The open source project started from infrastructure code published in a book, Expert 1-on-1 by Rod Johnson in October 2003, and I guess it was 2002. Okay, and its first release under Apache 2.0 license, and the very first version was milestone release 1.0. Okay, sorry for the spelling, it might occur in the tutorial many a time, but if it's code I will correct it soon. So let's concentrate here. So I guess this is enough to know about the history of Spring, the person, this Rod Johnson, who has and who should be credited for giving us such a nice framework for developing so robust J2E applications. And as stated by Rod Johnson, Spring's main aim was to make J2E easier to use and promote good programming practice. It does this by enabling a POSO based programming model that is applicable in a wide range of environment. And at this moment I think I can now introduce you to this framework. Spring is nothing but inversion of control container for the Java platform. What I said is inversion of control container for Java platform. What exactly is this inversion of control? It might be a new term to you if you haven't learned this technology or haven't heard of this framework earlier. So don't worry, I'll be explaining each and everything in detail. Inversion of control and the container it is acting as for the Java platform, and how exactly you can make use of it in your development. So if I say about inversion of control, or if I talk about this definition of IOC, in short, is nothing but it's an object-oriented programming practice whereby the object coupling is bound at runtime by an assembler object and are typically not knowable at compile time using static analysis. So it might sound very technical, so let's try to understand it in a simple and easy manner. And the very first thing that you may encounter over here is a term that you have heard of, dynamic polymorphism. This is very important to understand dynamic polymorphism before moving or proceeding in with IOC's inversion of control, or dependency injection it is sometimes called as, like we say, is dependency injection. So understanding both this term will be easier if you understand this dynamic polymorphism. I know you know dynamic polymorphism from the concepts of core Java, but exactly a little refreshing will be required over here. So let's see here. I have Eclipse over here, and let's start with the welcome screen. Let's go here, and we have a project explorer. Let's start with the project. While new here projects, I need a Java project. Okay, so I go for Java project, new. Let's name it here polymorphism test. Fine, so I can just finish it. No need to choose JRE JDK specification. You all know how to build this basic application. Right now I'm not going to write a Spring program, but soon, just have some patience. I am trying to make you understand the architecture, the concept, before proceeding on and start writing in the code. Okay, so let's say I have a package here. The name of the package, like I say, com.wordpress.srkplanet, the organization. Okay, and inside this package, let's take a scenario. Suppose I have a class here, a top level of class. Let's call it account. Okay, so this account is a general class, a generic class, as you can here. Let me increase the font here, as is the new I mean the fresh launch Eclipse, that's where the settings are not there. I say go here to editors, and in case of editors I come to the text font, and just for here I want to increase the font. Like me search it, colors and font, don't waste your time. Okay, so basic text font, edit, let's go for 20. Okay, bold, and that, yes, that would be sufficient. Okay, so we have a basic class over here called account, and let's say it has got a method here like withdraw. Fine, so it's a general class account, it has a method withdraw. Now let's say I have two another classes, I call it saving account, and another class, let's call it current account. As we know, this saving and current are two different type of accounts, so we can say this saving and current account are a kind of child of account, or you can say a type of account. So what we can do here, we can simply extend this account in saving account and in case of current account. Okay, just wait, I'm going to explain you what I mean by creating these classes and why I'm introducing you all these stuffs over here. So let's say I'm gonna override that method withdraw with my own implementation in case of current account. I say here nothing but system out println and welcome to, I say here current accounts. Okay, similarly as you can see over here, this arrow, this triangle pointing here, that it's an overridden method. This is a way of Eclipse to explain you that you are overriding a method. I just need to have this method over here also, public withdraw, and I will just change the message over here, welcome to savings accounts. Fine. Now in case of account, I don't have any implementation, I have rather implementation in current and saving, or better is to you go for the abstract classes or interfaces, but just for making you understand. So we have a top level of class, we have child classes, current and saving account, and now I have an implementation class. Let's write an implementation, I call it impl account. Here I have a main method where I'm gonna implement this and or test this particular functionality of this class. So how you access these functionalities, namely a withdraw function available in saving and current account? The way you do it is to simply create an object of type account and store a reference of type current or saving into it. Like I say current account, and I can simply say object of type account withdraw. So what we expect? We expect as an instance of current account is existing in this variable ACC, so accessing the withdraw method will execute the body of the current accounts withdraw method. Let's test it. Right click, run as JavaX applications, save it, the changes you made over there, and waiting for the console. Welcome to current account. So you got the current account. What exactly you did, you have a hierarchy over here, parent to child, and you are just creating a variable, generic variable of account type, and storing the reference of any of the child in it and trying to access the method. But why you are doing so? You could have created an object of current account directly and have called the function. Here what the term polymorphism comes into the scene. Polymorphism, just polymorphism, not dynamic right now. So what exactly this polymorphism offer is like having many form. This is an object, okay, sorry, a variable. This is a variable of type or a type of representation of account. An account is representing many types of account or many forms of account, like current account, saving accounts, or it may be fixed deposit or another kind of accounts. Okay, so the thing is, this is what polymorphism is, and right now what you are doing is static polymorphism, or better call as compile time polymorphism. Here we at compile time we decide the program flow. We decide that at compile time the program has an account type variable which will hold a reference of current account type, and this will be invoked every time you execute the binary, you execute the compile code, you are going to get the same result. This way it is a static polymorphism. But what exactly we need to achieve over here is dynamism. I want at runtime to be decided what exactly this account has to offer. Based on the user input, the user choice, whether he chooses for savings account or current account, the withdraw method should be invoked, or any other such method should be invoked. So what exactly I need to have over here? Well, enough, I need to have a function over here first that will provide the functionality. So let's say I create another class over here, and let me call this class over here as simply decide. Okay, and let's finish it. In this class decide, what I create is a function. Let's say let me call it invoke my account, and I pass here an object of type account. Here in this function you pass an object of type account, and based on the particular specific reference it holds for account type, it will call the method. Like I generically write over here withdraw. Okay, save it, and in the main that have here an implementation, rather than invoking the function directly at compile time, look here, I commented out the code. Okay, why I comment out that I don't want it to be forced at compile time to keep the reference of the current account or a particular saving account in the variable. I want it to be decided at runtime. So let's see here. What I need to do is to create an object of type decide class here, like say decide d equal to new decide, and d dot function invoke my account, and here you are free to pass an object of any type, like I say here new saving account, and that will do the job. First execute. I pass an object of type savings, I save it and execute it. So welcome to savings account. See the magic over here. Like I can provide a choice over here, give an input for saving, to choose one for savings and 2 for current. At ATM menu like you get over there. When you choose one, an object of saving account I will create and pass it to that particular decide class, or if you choose 2, I will create an object of current and pass it to the current account class. And there at the decide class, what I'm trying to do is invoke the withdraw method. All this is happening at runtime. Again, you might be questioning me, this is what you are doing, I can do it at compile time by simply having this particular object creation depending on the user's requirement and invoking the particular object. Like you say 1, I will create an object of saving account type and I will call the withdraw method. But the thing is, in that scenario, if you have, like what I'm saying is, if choose 1 for saving, I'm not writing the complete code, okay, and choose 2 for current, what you can suggest me here, why you are writing so much line of code? I will create an object of type saving account here equals to new saving accounts, and I can invoke the withdraw function if user chooses 1. Like I can write if 1, or else it is going to be if 2. You will say I will create an object of type current account and simply I will invoke the withdraw method through it. So what is the logic, what is the idea behind the term using a dynamic polymorphism? Why should I go for this new class? The thing is, if you code your application in this manner, it is going to be a very highly coupled application. These objects saving and current will be highly coupled with this implementation class. Any logic change, any changes, any new any new concept or terminology, any kind of functionality you are going to add to this particular implementation or to the savings account or current account will have an adverse effect on the functionality of the program. This coupling will make the application less prone to changes. It means if you want to change, you have to make changes at a lot of places, and a lot of things need to be done. Like for suppose in savings account I just introduced a constructor. So what is going to be happen, I need to come to the implementation class and I have to make that constructor also over here changes, and similarly lot of dependencies where there will be in case of this implementation current and savings account. So in order to reduce those dependencies, those implementation, we have this option of dynamic polymorphism. And another reason why you are going for it is at compile time, like you don't want to have this complexity, you can have an account type generic object, you can store an object of the type any current or saving and just invoke the functionality over it. But still, if it is in the same class, that is the implementation class, there is a risk or chance of exceptions or errors at runtime. Suppose the objects are not going to be created over here. Objects are going to be created by a client using some another implementation class. They create the object of saving or like say current account, and they invoke our function passing their object to our functions. When they pass their specific objects to our function and we try to invoke some functionality which is not existing there, that can result in runtime exception. This is the case, this is a scenario that happens, and this is what we need to avoid over here in case of dynamic polymorphism. What I'm trying to say, what you did over here, see, you have created a variable of type account and you say acc.withdraw. What if this particular account, saving account, or this current account is having another method, like I say here, public void overdraft. This is one of the functionality we have in case of current account, and we are not going to discuss the banking terminologies over here. Current accounts overdraft section. So this method overdraft only exists here in case of current account. It is not associated with savings account. Okay, so what you will do over here, in case of this decide method, if I try to invoke through the generic object or the base class object, this method won't be accessible, cause this method right now just I created, this overdraft is not defined over here. Like you can see here, this overdraft method is defined here in the current account class. It does not exist in saving account, nor it exists in account. So through a variable of account type, you cannot access this overdraft method. Here in the decide section, you cannot write acc.overdraft. It won't exist. Of course it shouldn't. This is the nature of the objects. The methods are defined over here in the top class, and only the methods available in the top class will be available through its variable. And if it is overridden by the child, and if you are passing an instance of child to this parent class object variable, then only you can access the overridden methods of the child. But in case if I know, I'm sure that here, let me delete this code because it is maybe creating the confusion here. Like I say here, I'm passing a saving account type object, or I'm gonna pass over here a current type object. If I'm sure of it, what I can do here, I can simply typecast it back into current account type. What exactly does it mean? I say create an object of type current account called CA, typecast it forcefully over here, current account ACC. It means if you pass an object of type account, you know it. From the principle of this typecasting over here, we can, if the particular child reference is stored in a parent class variable, we can restore it back, or what we call it is a downward casting we can do over here for an object, and we can get the current account over here. Now through this CA, if I try to call withdraw, of course the withdraw method of the current account will be invoked. At the same time, you can see here overdraft will be available here. So now you can access the overdraft method over here by typecasting it back into a specific type. Now let's test it whether it's working. So come to the implementation class, I try and run over here. So welcome to the current account and overdraft section. Now again there is a problem. Suppose instead of current account, I pass over here saving account. Okay, so now there is going to be an issue. Definitely you pass a saving account object. This ACC right now doesn't know what exactly the object you are going to pass. This happens at runtime. This is what I'm talking about. At runtime, an object of type account, whether it is saving or current, can be passed, and I assume a current account object is going to be passed, so I forcefully typecasted it back into a variable of current account type and invoke both the method. But what is exactly is going to be seen here, at runtime an object of saving account will be passed to this function. At compile time, no knowledge, no idea this object has about this. So when you try to invoke it, see, as you can expect here, you are going to experience an exception over here like this. Exception in thread main, class cast exception. This class cannot be casted. You have passed an object of type saving and you cannot typecast it back into current. So what exactly you need over here? You need to make a decision. Need to make a decision. Why I'm writing this, I will make it very clear. This decision making is what something the container, IOC container in Spring will provide you. Don't have to make a lot of comparisons and things. We'll talk about it later. Okay, so come here. What I have over here is instance of operator in Java that help me make decisions perfectly, and depending on the runtime object being stored or referred in a variable, we can invoke a particular object of that type. Like I say over here, if ACC is instance of current account, then only this code or piece of code should execute. Else if ACC instance of saving account, what you should do here, create an object of type saving account, like call a saving account here and just assign ACC in it. And as you know, saving account has got only one functionality, that is withdraw. No other method or functionalities are there. So now you are sure that every time an object of saving account is going to be passed, this word drop will not be invoked, only the withdraw method of the saving will be invoked. So let's test it here and just see here, depending on the object at runtime. Welcome to saving accounts. Or if I change over here, let's see here, at runtime this is happening. Whatever you are passing here, that type of object, that type of functionality getting invoked. This is the magic of dynamic polymorphism, what you are experiencing over here. And what exactly right now I'm hard coding it. It's not actually going to be the scenario and runtime or in actual development environment or production codes. What happened, user has the choice. He creates the object, pass it to a specific function. He doesn't know about the functionality, just create an object, and that object at runtime will be going to be injected into this function, and that particular function is going to get a reference of that particular type casted back and will invoke the function. Here we don't have risk of any kind of exception, class exception or things to be seen. You might have seen lot of functionalities, lot of discussions about polymorphism in books also, where we have classes alpha, beta, gamma. We are creating an object of type beta, storing it in alpha, creating object of gamma, typecasting it back into alpha, and kind of thing it is happening. What exactly this upward and downward casting is all supposed to do is something the scenario is describing you. Now you can be very clear of what exactly this dynamic polymorphism is and what are the benefits of it. Like here you can see there is no coupling among these components, and as well as we are free to choose any method, any functionality from any object at runtime. The decision is completely made over here. So we have this concept, this idea, this thing in the framework in Java itself, the language. So why we are going for a Spring, the term arises from here, inversion of control, as I was talking about. Inversion of control or dependency injection. So at this moment, when you have reviewed this concept of polymorphism, I guess I can introduce you this inversion of control. And let me just remind you about what I was saying at that moment. What I defined is IOC is like an object oriented programming practice whereby the object coupling is bound at runtime by an assembler object and are typically not knowable at compile time using static analysis. Let me type it over here so that you can get a clear understanding. Inversion of control, in short we call it IOC, is an object oriented programming practice whereby the object coupling is bound at runtime by an assembler object and are typically not knowable at compile time using static analysis. So let me explain, or I guess you might have understood it, but still for clarification. So IOC, what Spring offers, is an object oriented programming practice. Right now we are practicing something over there whereby the object coupling means the kind of dependency we are going to have between this, let's say, implementation, current and saving. This coupling of these three classes, as in our case, is bound at runtime. You can see here at runtime the decision is going to be made. Here in implementation we cannot decide which specific functionality will be invoked. Let's say I am having a client class, another class apart from this implementation. That class is creating object and passing to this particular implementation account. An implementation account is further passing it to the decide object. Or let's say we have several implementation classes, okay, created by several clients. At that time, what exactly the statement says, that is an object oriented practice where object coupling is bound at runtime by an assembler object and are not knowable at compile time using static analysis. Like when you look at this code, you cannot say which is going to execute, which type of account the client is going to invoke. At a time he might be using a current account transaction, or he is going to have a saving account transaction. This IOC is what exactly is similar to the dynamic polymorphism we have, but IOC is not complete over here. There is lot more thing that you need to know about it. Actually, the thing is, what exactly Spring offers you is a container known as IOC container. Now I can say Spring is inversion of control container for the Java platform. You might be getting a little bit confused over here. What is this I'm trying to tell you? Let me make it very clear by having a diagrammatic approach of explanation here. You all have heard about the term servlet container, I guess. The servlet container, what exactly it is? Tell me. Servlet container is nothing but it's a kind of implementation for the servlet based technology that helps you manage the objects, providing you various services at the server side. Like for example, let's say I'm having a server over here. This is going to be my servlet container. Okay, here what we have, the servlet container. Another thing is, let's say we have some clients over here. We have first client, we have second client, we have third client. All they are trying to invoke some of the functionality written there in case of our servlet component. Let's say I'm having few servlet components as well over here, servlet A, servlet B. These are the clients. They are trying to access this servlet container, and as a developer, what exactly you do? You sit in your machine here, the developer develops the code, write the logic, only the business logic part, and host it to a servlet container. And we don't worry about the management of the life cycle of this object. We know whenever a request comes, the servlet container has the responsibility to instantiate the object, execute the service method, and return back in response the particular logic to the client. As this servlet container is managing all this logic, providing you this functionality, relieving you from the task of managing the life cycle of object, transaction, threading, concurrency, and security. Lot of more things are there, filtering, interceptor in case of struts, or lot of things. All these things are managed by the framework's container. A similar kind of container we have here in case of Spring. What Spring offers, let me now just change this piece of text over here. It's not going to be a servlet container, but you can just simply compare it like this. Let's say I have, in case of this Spring, I have IOC containers. Okay, we don't have here this concept of servlet container. Let me just cross it so that you might not get an impression of like I'm using this term. No servlet container. Okay, it is IOC container. So we have something in a Spring called IOC container, through which you, the developer, okay, so let me write here the developer to be clear, developer, and here let's say these are the clients. Okay, so I have 3 clients over here, 3 or n number of clients we can have in multiple scenarios, clients, and clients. So all these clients need to have some functionality which the developer has coded using the Spring framework. In that case, what happens actually, let's say I'm having an object over here. Okay, this is an object of type, let's call it saving account, and you want this object, or at the same time, let's say I'm having another object here, let's call it current account. Okay, current account. What exactly the thing is, we have saving account and current account object. We just have, or we as a developer, we want to write the logic, business logic for saving account and current account. The task of dynamic polymorphism, invoking a specific function, understanding the request what the client is making for, and then creating an object of that type and passing it to the client, will be all handled by this IOC container. It means, what I'm trying to say, that objects that we have over here that we have developed, at the same time we will create certain configuration. We will create certain configuration in the form of what we call here as the, like we have in case of servlet container web.xml, the deployment descriptor which describe what is the URL pattern to access a particular servlet, which class this particular name is referring to. If you remember, you have the web.xml in case of this particular servlet container. Let me write it over here. We have this web.xml in case of this servlet container. What exactly servlet container does? When a request comes from the client, servlet container tries to invoke this web.xml file, goes along with the parsing on other process of XML files, and sorry, the L is being left over here. I hope you understand. When web.xml file it reads, it simply understands the request, like a client is making for a request based on a URL pattern. That pattern is mapped to which specific servlet class. Now this servlet class is belonging to which package, and in that package which class, it just execute the service method do get and do post, prepare the response and return it back to the clients. The same kind of task, let me cross it out over here, web.xml. Rather than having this web.xml over here, what we are going to have in case of IOC container is what we call here an XML configuration file, or another nature of configuration like spring.xml or bean.xml, or you can name it anything you want. It's not necessary to name it spring.xml. Only what I say is configuration file. Why exactly we have this configuration file? You understand it from the scenario I was talking about, the servlet container. So what will happen in our scenario when we are talking about its IOC container? Simply the Spring framework will read the configuration about the classes, how we are going to instantiate it using this configuration file. This Spring framework will do all the rest of the tasks you don't have to think about. It will simply see what the request is coming for, what kind of object is demanded by a program or another class, and it will simply reading the configuration, instantiate the object inside the IOC container. It will inject that object in a particular requester object and will return it back to you. The same thing, that all of these specific tasks, when we are going to test in practical, you will be getting a clear understanding of. For now, just map this IOC container as similar to that of a servlet container, and all the functionalities that it offers, we'll discuss it soon. And basically this particular technique that IOC is going to implement over here for mapping from the configuration file back to the client is something like called factory pattern that we need to discuss, and after this factory pattern we will start building with the application. For now, I guess this is like you can just go through, review it, and once again you can view the video starting, and then we can come back to the second part of the tutorial explaining other facts. Thank you.